Let's take a look at finding angle measures. But before we do that, I would like to review a theorem with you. And that theorem is called the angle bisector theorem. It says that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. If a point, in this case is point C, it's on the bisector, this line is bisecting, or this ray is bisecting this angle. These two angles are equal. And if this point is on the bisector of the angle, then this point is equidistant from the sides. And notice, anytime you have a point and you want to find the distance of that point to a line, remember it's always the perpendicular distance. So AC will equal CB because it's on the bisector of this angle. Angle bisector theorem. Knowing that, let's look at this figure. Is point M on the bisector of this angle? Yes, it is. These two angles are equal. And according to the theorem, if that's the case, then this point is equidistant from the sides of that angle. And it's also perpendicular. So now I can say that JM is equal to ML. In this case, we're trying to find the measure of ML. Well, MJ, or JM, is equal to 9.5. What's ML equal to? ML is also equal to 9.5 because of the angle bisector theorem. That's pretty simple. Let's look at one more. This time we have, let's see, here we go. We have a point in the interior of an angle, and the angle is ABC. We're also given that the measure of angle ABC, this whole angle, is equal to 136 degrees. We're being asked to find the measure of this little angle that I've marked. We want to find the measure of angle ABD. Now we know the whole angle, which is 136. What's this one here? Well, look at something. We have a point D that's in the interior of this angle. We also notice that from this point to the sides of this angle, these two sides are equal to 54. There's another theorem that you need to remember. And this theorem says that if you have a point in the interior of an angle and it's equidistance from the sides of the angle, which it is, then it is on the angle bisector, making these two angles equal. Well, knowing that, point D is in the interior, point D is equidistance because they're both 54. Therefore, point D lies on the bisector of that angle. Well, if the whole angle is 136 degrees, what's each one? Just simply divide 136 by 2, since I have two angles and they're both equal. And what do we end up with? We end up with 2 into 13, at 6, 68 degrees. So the measure of angle ABD is equal to 68 degrees. Okay? Let's try another one. to find in this problem? Well, let's see. We're trying to find the measure of these two angles. Well, we know what they're equal to in terms of x. If I knew what x was, then I could just substitute and find the measure of each angle. But what else do I know? What else do I see? I see that point U is on the angle bisector. How do I know that? According to the angle bisector theorem, if you have a point that is equidistant from the sides of an angle, and this point is equidistant from T and R, and it's also perpendicular, then this point lies on the angle bisector. So what can I say? These two angles are equal. So I'm going to write the measure of angle TSU is equal to, that's this angle right here, is equal to the measure of angle RSU. They're equal. Well, let's substitute. In place of TSU, I'm going to put 6x plus 10. And in place of the measure of angle RSU, I'm going to put 9x minus 17. Okay? Let's solve for x. Subtract 6x from both sides. We get 10 is equal to 3x minus 17. Now what do we want to do? We want to add. Let's take the 17 over by adding 17 to both sides. We get 3x is equal to 27, and x, divide both sides by 3, x is equal to 9. Okay? Now let's take this value. We're still not through. Let's take this value for x and go back and substitute in place of the x here. We get 6 times 9 plus 10. 6 times 9 is 54 plus 10. So what do we find? That the measure, this is equal to 64 degrees. So the measure of angle TSU is equal to 64 degrees, and so is the other angle, equal to 64 degrees.